This is a T-1200SRA from IFR. Now, I first saw this and it was screaming service monitor at me, which I suppose it is, but I did some digging around and it's actually a surveillance receiver. That's what it was specifically designed for. So this is the sort of thing you'd take in the field, or government bodies would, and go and track down and monitor radio transmissions. It's quite a capable receiver. It's got a tuning range from 100 kilohertz to 1 gigahertz. We've got some multi-mode receiver, so we've got AM, upper lower sidebands, and FM, and we've got on the AM we've got a choice of a narrow and normal filtering, and on FM we've got narrow, mid and wide filtering. We've also got an antenna switch, because we've got two antennas. We can switch in there, so you can switch between antenna 1 and antenna 2. We've got a marker, which is coming up here, which I'm not quite sure what that's doing, but it's probably something you have to do to calibrate it. And we've got a modulation meter, so that's adjustable by this switch. We can actually turn it again and get it onto batteries. So that's just saying our battery's healthy. And we turn it into that position, that puts us into a signal strength. So it's now displaying a signal strength. And we're currently tuned to a station. It's probably dropping out now. Yeah, so it'd be 838.8 kilohertz. I imagine that's the frequency. I think I've got that right. But you can actually tune it. I mean, it's just a case of, yeah, no, it's all normal stuff. If you want to change this change rate, the resolution of your tuning, that's medium, and then your F, which I imagine means fast. Yeah, so if we put that on this. Oh, we can see that station there. So this is coming in with a fault. It's got a problem on the USB, I believe, where the error meter isn't working properly. So we'll have to take a look at it. So the first thing I'll do is get it on a signal generator, and we'll send a single sideband signal into it, tune it in and see what it does. Okay, so if we take a look at the actual fault it's come in with. So if you look, we're on lower sideband. I mean, there's no antenna connected to it. I'm not injecting anything from the SIG-gen. Obviously, there's nothing plugged in. And you can hear that. There's that noise. So if I switch on to upper sideband, it goes very quiet. You can hear a bit of processor noise. I'm not sure if that's correct. Probably not. Probably it might be capacitors filtering. But I can't see that's going to cause us the problem. So if we flip round to, it's the same, narrow FM, that's deathly quiet. There's nothing there at all. Normal, there's some background noise. FM, mid, wide. We can see there's a problem, and let's just stick an antenna, let's stick a signal into it. Okay, so I'm going to inject a signal at minus 70 dBm. This is going to be a single sideband signal at negative 1 kilohertz, which will give us lower sideband. And let's switch it on. Yeah, well, that's coming in. That seems to be fine. We can see the signal on the spectrum analyzer. Yeah, it's on signal. I'm not sure how this is supposed to be working, but we're getting something. It's receiving, so let's go to upper sideband, and I'll change the modulation frequency to +1, which should be, so it is working. Signal level seems about the same as well, but we don't seem to be getting anything on the signal meter. And I can actually wind that up Let's just turn that. Yeah. Okay, so that's minus 40 dBm. It should be blowing its windows out. So it's deaf on upper sideband. And let's have a look at AM. I'll just change the modulation to AM. And yeah, so I'll put a 20%. In fact, let's turn that up. So it's got a 40% modulation index, and we're at minus 60. And you can actually see that on the analyzer. It's there, but it's very quiet. Getting nothing on the meter. If we go to normal, yeah, that comes straight up. So the problem is definitely on the, the problem's definitely on the upper sideband and the narrow. So there's something in common there. The narrow may be sharing the same filter. Now I'm not sure exactly how these work, whether you get it shifts the local oscillator to adjust the upper and lower sideband into a filter, but yeah, we'll discover that. There is absolutely nothing I can find on this particular unit, with regards to service information, schematics. Now there is an S, it's a 1200S, which is just AM FM, but it's a completely different beastie because it's got signal generators built into it, and it's a service monitor. As I said, this is a receiver, and that's what this thing is. So when we go inside, you'll see that this thing is built like test equipment, and essentially that's what it is. So this is the underside of the unit, and I've just basically got to try and figure out what's going on. So I've had a look at it, and what we've got is at this point we've got the antenna inputs that go into this unit. So we've got one antenna input here and another antenna input at that point. Now that's a switch box, so when you turn the switch for antenna A or B, 12 volts appears at this point, and it must be pulling a relay over. So the output of this comes down and it feeds into this unit here. Now on the service information I can find for other models, sections of this are quite similar, and this is a mixer. So there's actually two mixers in here. Now exactly how it's working I'm not 100% sure, but I think one of the mixers, or it's actually being used by the spectrum analyzer, and then we've got the other side, which is obviously giving us our receive signals. Now as you can see, there's quite a bit of RF plumbing going on in here, and I'm not entirely sure exactly what's going on. However, I do know that this is producing a 10.7 meg component for the receiver, which we'll take a look at in a second, which goes up onto the top section. But the other things we've got in here, this looks like a ovened oscillator of sorts. Exactly what frequency it's running at, I don't know, but I think that's just simply, that's the reference oscillator. And we've got some connections here to obviously power it, and there may be some monitoring going on to say when it gets up to temperature, so it's just to keep them stable. Other things we've got here, this looks like a crystal filter, little enclosure, and exactly what that's connecting to I don't know, but that if it's a crystal filter, it could well be just a bandpass filter. And maybe that's conditioning the signals coming out of the mixer, which would make sense. Down here, you'd first look at that, and when I looked at it and I thought, well, yeah, it's a step attenuator maybe, but it doesn't appear to have step attenuators in it, and it really wouldn't make sense as a receiver. Or maybe, yeah, it could be for the spectrum analyzer, could be, I'm not sure. And we've got this unit here, which seems to have all these tuning points, which looks to me again like some sort of filter, you know, with various orders that you can actually tune. So that could well be a bandpass filter. Not sure about this, but we know we've got a 10.7 megahertz component going up to the top side, which I imagine is, you know, will contain the signals that we're wanting to receive and demodulate. If you look here, we've got a broken tantalum capacitor, and I don't know if you can see that there. There's been some damage on the board. Now, this panel I've actually managed to find a circuit for, and what this is just, it's basically the power distribution board for the power supply. There's a switch mode power supply that's actually in here. You know, it's tucked away at the back there, and the pins come through and they solder onto this board here. And what this is the minus 12 volt rail. So you know, tantalums, anybody knows experience with them, they don't like especially when they go old, they don't like voltage spikes, and they could just go short. You know, and when they go, you know, they really go, and the power supply's got plenty of grunt, it will just blow the device, and that's what it's done in this case. But I've tested the voltage here. This is at minus 12 volts, and that's all present and correct. In fact, all the voltages are correct here, and they look reasonably clean. This will need to be replaced, obviously. And this transistor that's here, now this makes up a circuit for controlling the charging of the cells, because of course this thing's got the cells in here. I think they're little lead acids, I'm not sure. It could be NiCad, I don't know. I haven't gotten that far into it, but that, you know, needs to be repaired as well. Now it is working, it is charging, but I don't think it's working properly. But for the faults we've got, I don't think this has got anything to do with it. In fact, I'm really certain of it. It may have been that this has come from the United States, and somebody, you can plug it in on the mains, and somebody may have put 230 volts onto it, and it kind of reacted to it. However, yeah, I'm not sure. It's actually, there's a setting, you can set it between 110 and 230, and it is set on the 230 setting. I've not put any power on this. We're running this via a little 12 volt off a DC bench power supply, so it's just 12 volts DC, and I'm feeding it with. So we're going to get back to this. I want to get to the main faults. Okay, so let's take a look at the top section. On this side, we've got all these little modules that drop in. Again, this is, you know, you don't see this in receivers. This is really sort of top-notch stuff. I'd say this was a very expensive receiver. So the things I'm interested in, well, I'll just go through it. You can see here we've got it's got a logarithmic amp, it's got an IF analyzer, and it's analyzer RF, which is all to do with the spectrum analyzer. We know our signal's constant, it's getting the signal, it's not being lost at that point. Well, it doesn't appear to be. So here we've got, it's saying a 10.7 megahertz receiver. Now, this is a thing of interest, and this connects over to here. I don't know if you can see that, but that's basically saying that's a product detector, and that is the, you know, again, maybe a point of interest. So what I'm going to do, I think, from what I can figure, because this looks like it's coming up from the mixer, so I reckon that our signals at 10.7 megs come in at this point. So what I'm going to do is stick a signal generator on this and intercept the information, you know, the RF signal coming up here. We'll have a look at it on a spectrum analyzer and, you know, see what's coming up there, because if it's not, you know, if that upper sideband is low coming up here, then the problem's going to be mixer, the other end of the mixer. Or if it's all present and correct, the problem's going to be either in here or in the, you know, in the product detector. Okay, so we're injecting a lower sideband signal. We set to lower sideband from the, you know, obviously it's from the signal generator. And if I lift that off now, that comes away. So okay, so if I put a scope on that, a scope probe rather, onto that connector. Okay, so let's connect that up. That is our tone. We're injecting minus 30 dBm. It's quite high, I know, but I just want to see what's happening. So if I turn the receiver to lower sideband, hasn't made a blind bit of difference. It's exactly the same. So if it was going weak, I'd expect that to come down, but it's not. It's staying stable. That's on narrow AM as well. Sorry, that's just me on the scope probe. So you've got to be careful. They're very strange connectors. You've got to be very careful with them, because if you stretch the damage the pins or anything, you're in for a world of pain. It doesn't matter what we switch to, that's the same. So what that's telling us is that the signal is coming up from the mixer, so it's getting mixed up and it's there. We can just prove that. We can just say, look, signal generator on, signal generator off, signal generator on, signal generator off. You know, that scope probe is just literally feeding into the spectrum analyzer. So everything seems to be present and correct there. So let's see what's coming out. Okay, so as I said before, that's what potentially the IF, the 10.7 IF, or it's called the IF. It's called the 10.7 megahertz receiver, and we've got this coaxial cable here, which I'll see if I find something to point with here, which comes over to this module, which is the product detector. So what I'm going to do is just disconnect this here, stick the probe on and see what we've got coming out. Okay. So that is lower sideband. Remember, this is the output of the IF amplifier. That's basically what it is, and I imagine it's filtering. And when we switch to USB, it's appreciably, you know, that's a lot smaller. So for some reason, our signal's getting attenuated in that module. Okay, so I'd say we've got a problem in there. Let's have a look on narrow. This is, hold it. Yeah, this is narrow AM. Yeah, and it's still low. It's not quite as low, but it's a lot higher on LSB. So I'd say there's a problem in there. I'd say that's where the problem is. I'm just going to check some of these ribbon cables to make sure that it's getting, there must be filters in there and it has to be switching them over. So there'll be voltages coming up those ribbon cables. We've got a ribbon cable here. This goes from this board, which is doing some panel management of switching and stuff, I imagine, and this goes up to our IF 10.7 megahertz receiver. So if you look on the meter, obviously we're in DC volts, one side's tied to ground or the chassis, and if I put, there's a pin here, that's giving us 11 volts, somewhere on up if I can hold it there, and if we go to upper sideband, it goes to -10. Now there are differential amplifiers on this board which are fed with positive and negative 12 volts, so I imagine that's okay. Okay, and if I go, so that's on lower sideband, and then there's a pin adjacent to it. Okay, that's -10, and when we switch that onto upper sideband, yeah, it's giving us 11 volts. So I'd say that's switching. So I think the next thing to do is get inside this module. Okay, so I've removed this panel. It's, you know, that's all it's saying on there. It's a 10.7 megahertz receiver. Obviously it's a DES series. There's some code numbers, but that's where our signal was coming in. Now I've just removed these two screws here from the back, and it should come apart. Ooh, okay. Now, got some crystals here, and there's two enclosures. Looks like we've got two, they look like crystal filters. Ooh. And some circuit boards and more screening on this side. Yeah, I mean, it's not really telling us a lot. So these are all saying 10.7, 10.7, 10.7. So maybe they might be using the crystals as part of filtering, probably. K and L. Now K and L make filters, so these could well be filters. So on the underside, I've had a look through it. It looked okay apart from here. And if we look carefully, you can see that's come away. There's I imagine that this comes out of this crystal filter. And imagine that should be soldered on there. And I don't know if we can get any closer zoom, but it looks like there's little joins in these sleeves. A thing I've also noticed on this is, you know, we've got all this, you know, handwritten stuff all over it. It's all over this unit. Everything's got writing on it. Yeah, and if you look on this side, I don't know if you can see that, but these have all got little links in them as well. Now, that doesn't look very good for a company like IFR. You know, I would have definitely thought that, you know, sort of quality control, they wouldn't release something like that unless somebody's been in here, but it didn't look like it. The screws were incredibly tight. You know, like they had never been cracked. The heads all seem fine. And it's got these writing. I just wonder if this is a prototype of sorts. It could have been a prototype. Now, I know I've done a bit of research, and there was very few of these made. The SRA was very, very rare. Someone was saying that it was less than 10 of these were actually manufactured. And I just wondered if it was this was a prototype of sorts. I don't know. So I think the thing to do is see if I can solder that back on. Now I imagine that's where it's come from, here. And get it back in the room, which would make sense, because if the upper sideband was sharing the same filter as the narrow AM, which would make complete sense, that could be all our problem is, which would be nice. It could, I say, because if you say that's the problem, then you find out that it's not, because it's, Murphy's Law. So, yeah, let's see if we can fix this, repair this, and get it back into the set. Okay, for the soldering fanboys, we're going to solder this on. So we'll see if we can solder it back to where it should be. So if I pull this, if I can, gently. Okay. I just want to cut a little bit of this sleeving off because I think it's just a tad long. I think that's probably why it's come off. I don't like it. I don't like it at all. I don't like the way it's all been done, but oh, come on. So if I just cut a little bit of this sleeving off, only a tad. Okay. What was that one? Was it? Yeah. I don't want to solder it to the wrong one. Okay, looks like a dog's dinner, I know, but that's the way it is. Just have a quick look at that under the... Yeah, it looks all right from my house. So we've got the board now reinstalled. Obviously we've repaired it, and let's see what we've got. So that's lower sideband. Upper sideband still quiet. If we go to narrow, it's now working. And if I can set this, so we want modulation. We'll just set modulation to AM. Audio frequency tone, 30 megahertz. And let's switch that on. Yeah. Narrow's now working. But we still don't have the upper sideband working correctly. It's still deaf. So I'm going to go back into that board. Yeah, I've just got to try and figure out a way of being able to sort of test on it while it's in circuit. So it doesn't. It's not on an edge connector on a motherboard at the bottom. It's just literally all connected at the top. So. But I don't think the ribbon cables are very long, so I don't know, we'll figure it out. Okay, so we've got to the bottom of the problem. Obviously it's the USB that's causing the issues. And what I found is obviously this doesn't work like a conventional super het receiver. Normally a super het receiver will have one crystal filter. This has two for the sidebands. So what happens on a sort of a normal sort of, I'll say normal, you can't really call it normal, but what they do with I said it again, didn't I? What they do with super hets is they generally use one crystal filter. And the crystal filter will have a set frequency. So in this case it's 10.7 megahertz, and it'll have a bandwidth. So if it's a 3 kilohertz bandwidth, it'll be positive 1.5 kilohertz and minus 1.5 kilohertz. So what happens is, so to use the filter on upper sideband or lower sideband, on upper sideband, it's fine because the will come through, the signal will come through on the positive side of the IF frequency. But on the LSB, what we do is inside at the mixer, you actually shift the IF frequency, not the IF, you actually shift the local oscillator frequency, and what that does, that brings the LSB signal into the bandwidth of the crystal filter. So that being said, what's happening here? Well, this doesn't work like that at all. So this is fixed 10.7 all the time, no shifting whatsoever on any local oscillators for upper and lower sideband. What this does, it uses two crystal filters. So we've got one that's being used for upper sideband. Well, no, sorry, this is the lower sideband one, and this is the upper sideband crystal filter. There's another crystal underneath, that's for the AM narrow, which I think is about 3 kilohertz, 3 to kilohertz, maybe, I don't know. So what's happening is we're getting our upper sideband signal is getting to this point, and it goes into the mixer, and we're getting loads of insertion loss from when it comes out. It's working, and I've tested it, and I can show you in a second. We can show you how to test it. It is working, but that's where it's deaf, because the signal is really low coming out the back. I mean, they naturally have insertion loss. You know, it's the action of the, you know, the various parts inside, i.e. crystals. You know, it takes energy to filter something, so you will get loss. But the loss we're getting out of this is, you know, it's like, yeah, pretty bad. So I could show you, and what we'll do, first of all, I'll show you the LSB working, and then I can show you the upper sideband. So I've got, this is set up, I've got the signal generator plugged into the test set, the monitor, and I've got an input here going back in, that's for the spectrum analyzer, and I'm just using a scope probe. The unit's set to, we put in quite a big signal in, minus 45 dBm, frequency is set to 30 megahertz, modulation single sideband, and we're giving it minus 1 kilohertz. Or hertz, I don't know whether that's plural, I don't know. Anyway, doesn't matter. So let's get back. So what I shall do, so if you look at the screen, I'm going to put the probe on the input of the LSB crystal filter, and we can see, and if you look at the top there, this isn't going to be correct because I'm using an oscilloscope probe and it's on ×10, but it's just for an indication. So that's giving us minus 43 dBm, and if we look at the output of that crystal filter, that's given us minus 49. So you can see there's a bit of insertion loss there, but the signal's quite, you know, it's reasonably, you know, it's reasonably strong. Okay, so if we put this into upper sideband, so turn the receiver to upper sideband, change our modulation frequency to +1, we can now hear it. And then if we look on the input of the filter, this is the upper sideband filter, you see that's huge. It's even bigger than the one before. The reason it's bigger is because the AGC in the radio is just opening the gain up, so it's at maximum gain. And now if we look on the output, you can see it's there's a lot of insertion loss there. There's a hell of a lot. So there's some diodes that switch, and there's paths. I've tested it all, and you know, that's so that's the problem, this bad boy. Now these things aren't easy to get, because, you know, it's, I don't know, I might be able to get one, but we're going to have to go on the scout and see what we can find. Problems with crystal filters, you've got to consider obviously the frequency, which is, this is 10.7, but these are offset, so this will have a set, this will be like 10.7 plus 1.5 or thereabouts kilohertz, and then it'll have a 3 kilohertz span on that, centered on the 1.5 kilohertz reference. That's how it works. So in fact it's the other way around, but I'm not going to go into it, because what happens is, because we're down converting, it transposes the frequencies on the IF. So in, you know, this would be, the lower sideband will be the higher frequency, and the upper sideband will be the lower frequency. It's just how it works. But yeah, we're going to have to try and get one. So, you know, I'm going to finish this video here. If we can find one, I will make another video, and then we can install it, or if we can find another board. But these things are pretty hard to get. I would imagine this is not an easy board to get or filter. So Okay, well, if you've watched it all, I'd like to say thanks for watching. We'll catch you in the next video.